Hello there and welcome back to this video series on programming for problem solving using C language. After watching this video, you'll be able to use Union to your advantage. It is highly beneficial to watch video number 50 before you go into these details because it gives a little bit of background. With that said, let us look into the video itself. A union declaration and a struct declaration look very similar. The style of declaration is very similar, but the similarity ends there. A union has many elements of different types similar to struct. But the difference is that in the case of union, only one element may contain a designated value at any given time. That is, changing any one value will affect the other values. It may not be clear right away, but we'll try to see an example and it becomes clear. Okay. Union provides a way of looking at the same data in different ways. Okay, we'll try to see an example now, and then maybe in subsequent videos we'll try to see one or two more examples. Here a declaration of union is given. If you remove the word union and put the word struct to indicate a structure, it will be exactly the same, but as you can see the details are different. Okay, you defined a union test and you defined a variable fun which is of type union test. This fun has two elements. One is short integer fun.I. Another one is two character array, that is fun.c0 and fun.c1. You can see that a structure occupies only as much as is sufficient for the maximum size of the elements. This short int carries 2 bytes, and each of these characters C0 and C1 1 byte each. So if 2 bytes are given as shown here with 16 bits, it is sufficient to hold this union, because at any one given time either I is fun.I has a designated value or fun.c0 and fun.c1 have the designated values. This will be clear when we try to run a program and see, and further details will be given later. Let us say this is the program we have. Okay, the name of the program is union.c, and then a union test is created of two data elements, short int I and character array C of capacity 2, C0 and C1. We have assigned values to C0 and C1, not to test.I. Let us see how it takes those values. You can see that even when we assigned values only to C0 and C1, this fun.I took a value of 512. To see that, we need to go a little back into this slide. We gave C1 is equal to 20. In binary, if you see, it is 10. Okay, rest all zeros. Then C0 we have given 2. We have given C0 is equal to 0, all these zeros, and C1 is equal to 2, 1, 0. If this whole 2 bytes is looked at, it has a value fun.I is 512. So either changing fun.c0 or fun.c1 changes this fun.I. Or alternatively, if you assign a value to fun.I, the values of fun.c0 and fun.c1 are already assigned. It may look confusing, but it'll be clear if you try to look at several examples. That's all we have for now. Have a great day.